about 10 p.m. in night here. I'm not sure that what kind of time zone you have because this is Android worldwide. So I hope that a lot of people are watching me at this time, and so I'm very much excited to be speaking with you about our hottest and latest topic, Jetpack Compose. And oh yeah, I just recall that. Some of you must have submitted challenges for the Android Dev Challenge, and they would have received either Jetpack Compose building blocks, or they would have received some posters. So I got mine, and I'm very excited. It's very awesome, and there's a very little funny story on UI components as well. So you definitely would have liked it, and also you probably would have seen it on Twitter. So yeah, so I am a Google developer expert in Android, and I have been working on Android for like 7 years now. I'm currently leading Android team at a startup called as Airlift Technologies. We are currently running a product which delivers the groceries and fresh produce items under 30 minutes to people of Pakistan. We are live in like four cities at this time, and we are rapidly growing. Also, we are hiring, so if you are in Pakistan and want to join our team, please send us your resume and CV. I would love to have a talk about you. So today, this topic is something which I have been covering since Alpha 12 or Alpha 13, and over the time I have updated it for the latest Android versions, and now today this is for the Beta 5, which has been launched I think last week. So for the compose, you need two things. If you are new, totally new on this, first is that you will have to install a Canary version of Jetpack Compose Android Studio. You can't run Jetpack Compose applications on stable Android, so you will have to run a Canary, and a very good and easy option would be to install IntelliJ Toolbox, and you will have all these Android Studios stable beta and Canary in parallel there. So yeah, so let's get started. So as you might be aware that Jetpack Compose is a modern UI toolkit which simplifies and accelerates development, and it's a declarative UI just like React Native and Flutter, and only this time is for native Android development. So I actually wanted to, when I thought of Jetpack Compose, I said, okay, it's a UI creation tool, so everyone is creating UI. Why not have a little fun and create some games and animations in it and see how this differs from the usual transitions and animations APIs in native Android development. So apparently, it seems that it's very much possible and comparatively very easy as with the native development and XMLs. So it's very fun, it's very awesome. So these are some things. Obviously, I have not added some more latest demos. You will probably find a lot of on Twitter and GitHub if you search hashtag Android Dev Challenge, and you will see a bunch of these crazy wild animations on created entirely in Jetpack Compose with along with the source code. So yes, please go ahead and search it hashtag Android Dev Challenge, and you are not going to regret it. So these are some things which I have pulled from the Twitter and internet from the awesome folks like Alex and Group Singh, and some of them are mine. Like you can see that this Dino Chrome game, I this was the first attempt of my attempting Jetpack Compose with game development, and I had a lot of fun building it. And then this is a simple bottom navigation view which I created in Jetpack Compose, and it was like 80 lines of code. I can't imagine that how much this would take me for creating this in native Android development. It will be very horrible. So yeah, so today's topic is animations in Jetpack Compose. So when I first started working on animations in Jetpack Compose, I realized that there are a lot of APIs in the Jetpack Compose, and it got very confusing. Like in some samples, there is animate content size, then in some samples, there is animate star, then in some samples, there are transitions. So I just got confused and I thought, okay, let's explore each one individually and see that how they differ and what kind of examples and what kind of decisions they allow us to make and how they differ. So first one is I will be going through one by one from each and show you some couple of examples for each along with the code content. So first one is animate content size. So it's very easy. You have a snippet of a post. Let's say you are working on a LinkedIn application and you have a social media post, and then we see this read more, and we click it, and then post expands itself into the more text. So this scenario is all about animate content size. So we can do this. For example, I have one short text and one long text, and now I have this clickable switching state on the click. So whenever we click on short, it will be flipped to long and vice versa. So all I had to do is add this one, animate content size. So if you have already used Jetpack Compose, you will know that this is a modifier, and modifiers are sort of like XML attributes in our traditional approach, the text size and backgrounds and everything. So they allow us to, bring a lot of functionality and customization to our views through calling more and more repeatedly or in any order. So animate content size is a simple modifier which will figure it out that what is the size of the current view, and when its size is changed, when what will happen. It will automatically animate, and I just have to provide two different size text. That's it. So I don't have to do anything. This is not even a single line. This is a half line or one word function. So that's it. So now I can even customize this animate size, and this is not only applicable for the text. This is applicable for anything. So I have a simple box here, which changes the colors and changes the shapes and changes the height and width. So as like in the previous slide, I called this animate content size, but this time I provided some more customization. I provided that how much, what kind of tween and animation specification this content size should use. So I am giving tween. Tween is a linear animation, and then I am defining the duration. Okay, this should take half second, and then I have also an end listener that when the animation is actually ended. So you can add more animation specifications like spring, like acceleration, linear out, accelerate in, and keyframe animations and more. So animation spec comes with a lot of more twin options to even customize it more. So that was animate content size. Now we will move ahead with a little more challenging animated visibility. So visibility is like you have this floating button in every screen almost these days, and when you scroll it, its text goes down, text vanishes, and all you have left is a icon. So this is a simple floating animation, and the first thing I have to do is I have to add this annotation because these are the experimental animation API that is done. And now I have a simple floating button with row. Row is like a horizontal linear layout. Inside that I have one icon, this is this, and one text, that is it. So instead of adding icon and text in the same layer, I have wrapped up my text inside this animated visibility. So you can see that unlike animate content size, animated visibility is a composable instead of modifier. So this is a composable. Inside which you add more composable and more views. So all the views which you want to hide them at some point, you have to add them, add those inside this one. So Now I have added text inside it, and now I have two parameters. Number one is that expanded. So expanded is like this is a true false that whether animated visibility composable should show the children composable or not. So I have at this time flipped the state on the click to show and hide, and you can see in the below image that how this is switching the state. So now, like the previously animate content size, we have some more customization. So first one is inter animation. So inter animation is like you are telling, okay, I will be defining that how the part which is not visible should enter inside the visibility. So I am saying that okay, slide in horizontal. So we have couple of more like vertically and slide out horizontally, slide out vertically, and something like that. So in that I have first one is initial offset. So initial offset is like that what will be the initial position, and from that point this will animate. So you can see in the middle picture that intertext comes up slowly, and then animation specs is like the previous one that we have bunch of these animation specifications defined. So we can define that how much duration it is and what kind of easing it should have. So at this time we have 2000 duration, and similarly I have an exit animation. So this was about how content should come, and this is about how content should go. So you can see the bottom picture, it has both enter and exit. Uh, so when I click on that, the like button comes from right side, and then it goes down because I have defined the slide out vertically with the target of 100. So this will go 100 VPs down. So you can see more. For example, I had created this one, animated visibility. So I created four simple buttons and defined a variable which saved a state of which one is selected. So whichever it is selected, its text will be visible and others will be hidden. And this was merely 60 or 70 lines of code, and it was very easy to create this. Similarly, you can perform the animated visibility in columns and rows, and which will automatically animate and remove or add with animation. So it's very easy. Now you have seen the first how you animate the different content sizes, and now you have seen that how you can animate show eyed behavior of different composables. Now let's see with single value animation with animate star as a method. So this was previously the animate method, but then it was deprecated. And animate star as a state are like fire and forget. You actually uh, start the animation and you forget about it. It will end at some point, and it will uh, had some closure or endlessness as well. So animate star are like we have bunch of these methods for each kind of data type. So we have color, we have DP, we have float, integer, size, rectangle, and value. So these are a bunch of these methods we use at uh, depending on the situation we have. So for example, we have this very simple example where we are changing the color and the size of a button. So we have a button with a text, scale, and color, and then on the click, I am switching the state from one to other, and to create a simple animation. And then I have defined two colors. So I am saying that while color by animate color is state, and now I'm saying that if button is enabled, color is blue, otherwise color is green. And instead of using directly color dot blue or color dot green here, I am using this color here. So uh, that was it. That it. Now Jetpack Compose will actually animate from blue to green through this color. This will not have the fixed value of either green or blue. This will have a continuous value which will be continuously updated, and it will give us a transition from one state to other state. So similarly, I have defined the height and width. So I'm saying that if enabled, then 40, otherwise 60, and if width is if enabled 150, otherwise 300. So you see that this button actually increases its size, and same time it actually changes its color. And I can use these just like normal values, because these are the state values, so they will be automatically updated on each frame. So this will give us a very simple animation, like you could use it in bottom navigation with flipping icons or something like that. So it's very easy. So not only colors and these kind of things, we can actually mix multiple composables and create a unified transition. So for example, I have a chat that would tells me that whether currently the gender is female or male. So I am flipping it on the click again. So you can see that this time I have not defined any variables. I have directly used prefer size animate DP if it's female 100 and it's 250. So you see that this row defines the female image. And similarly, I have one more image of male where these values are flipped. So it's I also have defined here the border and border's color. So you can see that whatever is selected, it comes with a red border. So border size changes from 0 to 4, and its border's color changes from transparent to red, and vice versa. So this is about female composable, and then I have this is female image and this is male image. There will be almost similar modifiers on the reverse values. So now both will change its well both is change with state at the same time, and we it looks to us that okay, whenever I'm selecting male is coming up, and it's bringing decreasing the size of female image. So it's like that. So these are some more examples. Gurupreet Singh have a very fantastic portfolio on GitHub called as Cookbook, Compose Cookbook. It has a lot of demos and examples created all in Jetpack Compose, and it keeps updating runtime. So it has these has some examples which use this animate star as a state method, and you saw this male female, and we have this very simple menu where each button changes its location and changes its size and changes its visibility based on the whether button is menu is open or not. So you can see you can use a lot of more stuff with these because these are animations which usually run on some trigger. So it could be click, it could be any crawling, or it could be something like that. You don't have to keep a track of whether what kind of state animation is in, or when it's going to end or something. So these are fire and forget animation. Okay, so that was it. But these were for one-time animation. So if you have to repeat this animation fire and forget, then you will have to either manually repeat it, or you can use animatable. Animatable things make things a little more easier to understand. So, for example, we have a simple example of heartbeat demo where we have a heartbeat which continuously beeps up. So we have animatable is defined like that. So animatable, and we are defining initial value equal 1f. So see that we are not actually telling that what is exactly the end value or target value, because these are repeatable animations, and we will later define that when should they start repeating, at what point they should start repeating. So at this time I have said okay, color is initially scale is initially 1, and color is initially red. So now you cannot run we have a simple example of view model scope inside the view model. But similarly, we have a launch effect which allows us to run suspend functions inside Composable. So So in this particular example, what this launch effect is doing that this is like on start or on resume of a fragment. This is telling that actually when this composable uh, went into the life cycle, when this composable actually started. So I'm saying that okay, when this composable starts, uh, animation scale should animate. Now I'm telling that what is the target value. This is twice the size, and I am telling that what is the animation spec. So I am using animation infinite repeatable. So infinite repeatable is an another animation spec, just like tween and like that. So I am telling that how the animation will behave. So it will take 300 milliseconds of duration, and then it will add a delay of 1000 for the next iteration. And I'm telling that repeat mode is reverse. So this image is captured when repeat mode was not reversed. That's why you feel, shock. So suddenly it pops up to the original state. But with the reverse, this is like increasing, decreasing, increasing, decreasing. And then for the color, we have actually used instead of infinite repeatable, we have used repeatable, where I have told the iterations are two. So this will only run two times, and then button will only change the size, and there will be no change in the color. So these are for the repeated animation. And now finally I can use this animation scale and animate color just like normal value. So I have animate scale dot value, I have animate color dot value inside the composable method. So so now you must be wondering that okay, it was interesting, but how exactly should I use these animatable? So a real example and a good example of animatable methods lies in the canvas. So before we go ahead, let's go through a very simple basic view of canvas. So canvas is a spacer, and all it has to do is like draw behind. So whatever we pass in the onDraw method, that will be drawn inside that spacer. So now, Canvas already comes with a bunch of these methods like draw rectangle, over, line, arc, path, circles, and whatnot. And if you want to create your own method to call this in, remember that you cannot call a composable inside Canvas. We have to pass the draw scope method. So easier way is that you define an extension function draw scope dot draw my shape, and then you can call this draw my shape inside the canvas directly. So uh, so now, for example, we have a canvas, film X size, so it is going to take width and height. And now I'm drawing three circles with 300 and 200 and 100 radius and different colors. So this will give us this. It's just simple like that. So now, how you can leverage this with animatable APIs? So we have a simple moving box. So we have a position X animatable with a starting position of 0. And now when this composable, moving square composable comes in the live, I'm telling that it should have a target value of 500. So this will move from 0x to 500f. And we have infinite repeatable, and there is no reverse mode. So this is like coming back to the original point whenever. And now we have a canvas, and inside the draw I'm saying that okay, draw rectangle with color, but how am I supposed to use the value of animation X? So that will give us through transformation. So canvas has three transformations. We have translation, we have rotation, we have scale. So I'm saying okay, apply the translation here with animation position X value. So what this canvas will do that whenever it will get any value from position X, it will actually translate to that point and then draw. So this keeps drawing, changing the position. It looks like that this is animated. Using this simple formula, I managed to create a Dino Compose game for all the characters, and I also given talk about this as well. with a detailed explanation of how I created it. I will share the link, but you can see the code at this link. So Alex Lockwood created these dev and dev animations using this formula, and it has it's all about mathematics, So whatever you can draw and where that should be drawn is all about that. So finally, we have transition. So we saw the different use cases of animating the different composables, but what about coordination? What about we want to coordinate a lot of views and a lot of composables with each other, like this will come from here and this and a screen form and something like that. So that's where transitions comes in. These are like giving you full access to how exactly should be your composables move. So this is in a traditional concept motion layout of the Jetpack Compose. So for example, we have this Jetpack Compose where we have a exploding fab button, floating button. So in the start, we have a scaffold. A scaffold is composable, which gives us a top bar and floating and body and basic things of material design. So we have a floating action button, and I have defined a composable here, exploding fab button. So now let's see that what this composable does. So we have this exploding fabs button, and before that I want to define state. So we have at this time two states, one is normal and one is exploded. This enum will help us in figuring out that exactly at what position our animation is and what position it should go. So I create a simple state of this fab size, and then I define a fab transition. So you can see that we can define fab transition with transition data type, and I have to pass that what is the state of that transition. So update transition is a variable. It will take the initial transition of normal, and now I am defining that how exactly this transition will move. So I am saying, okay, fab transition dot animate float and fab transition dot animate color. So you can see that in our original example, we have two things. Number one is that this button increases its size, and number two is that this button changes its color. In this picture, there is no change in the color, but I will share the one more picture at the end of the transition. It will have a change of color as well. So we define the different states and the different transitions like this. So now inside that I say, okay, when state is normal, then size is 80, and when it's exploded, then size is 5,000. Similarly, I say that when state is normal, it's a secondary color, otherwise it's primary color. You might be thinking that we were doing this with animate star as method, then why this is necessary here? Because if you use animate star methods, then you will only be able to either change color or either change the size, but you will not be able to coordinate between different transitions. So this is where we are actually creating a synchronous transition with a lot of factors inside it. So at this time we have a fab size and color factors. So now we have this previously from the state and the transition, and we had the size and color changes from previous slide. Now we'll use these inside floating button. So our floating button is a normal floating button with an icon, and I am changing the state from normal to exploded on the click. And now all I have to do is that I have to tell it that this floating button size is coming from this one, and its color is coming from this one. So what happens is that when this transition starts, then it will change its value from our size was 80 flow 80 to 500 80 to 5,000. Then it will give us continuously iterative value. It will not give us the start and end. It will give us transitive value, and uh, it it may feel to us that exploding button is changing the size. because each time is getting the new value from the transition. So this was a very basic transition. Now we can add some more customization to it. So let's get back to our original fab side and fab color transition state. So we had this one like in the previous slide. Like we were using animate floor, and inside that we had this when that when it's normal its size is 80, and when it's exploded its size is 5000. Now I'm actually defining the transition specification more. So I'm saying that we have normal when normal is transitioning to exploded, and when exploded it's transitioning to normal. So this is transitioning to is a modifier of Jetpack Compose, and it will automatically pick up. So the purpose of this whole thing is that not only two states, you can add a lot of states, four states, five states, and you define that how from one state to second state this will actually go. So I'm saying that okay, when it's coming from normal to exploded, use the keyframes, otherwise use the twin. So keyframes allowed me to add a duration of 1000, and then I can put the value exactly. So I'm saying that okay, it's when it's 0 seconds, then it should be 80, and when it's 200 seconds, it should be 35. So you see that instead of increasing the size, I am actually decreasing the size at first, and then suddenly I am increasing the size to give that little bumpy effect that button was actually pressed. So this is how you are actually defining transitions in more details. So and this at the end this will give us like okay, button is coming back and then it's going down. So so we have this floating button of Joe Buck written a detailed article about this, and Ray Vanderlich also written an article about how to create this add to favorite button with transition. But please be aware that these are very old articles with using the old APIs, which may not be able to compile at this time with latest Compose beta. So I had a library of easy flip view, so I tried to create a compose version of it. So this is the blow version of how I created flip view. So now transitions gives you Jetpack Compose. Android Studio gives you animation inspector for Jet transition. So I have this rev enter button, and I can see that I can play and pause and drag it, and I have these states from idle to press, and I can flip animations, and this is giving me values like what is the radius at this frame, and what is the background at this frame, what is the text color. So you can actually get a lot more information using this, and this is very handy. This is very interesting. This allowed us to put more control on animation. So finally, Android Compose animations article gave this flowchart of which animation API to use at what time. So let's see. So we have a start, and now we are saying that okay, our animation is all about animation content, and if it's an animate content, and it has a enter and exim, if it has a animate content, and it has a now content can could be visibility or non-visibility, or it could be size. So if this has enter and exit, like this is coming and this is going, then animated visibility. Otherwise, it's there is nothing going and coming up. Everything is visible. So then we will use animate changes to content size. So I missed one crossfade in my talk. So crossfade is putting transitions in two screens. So we have default of left and slide in or fade in animation. So crossfade is like that. So it will actually animate your whole composable regardless of what is the content size inside. So if you have content size change, then go ahead with animate content size. Otherwise, crossfade is your best. So if I do not have anything related to content change inside it, so I will go to next step and I see that okay, my animation is about state based and can happen only composition. So that means that when the composable is live, then I come here and I say okay, my animation is infinite, so I will use infinite transition. If it's not infinite, then if I am mm, animating multiple values and multiple factors at the same time, like we saw in the exploding fab and flipping view, then I will use the update transition just like we use. Otherwise, I will use fire and forget animation for single factor. So transition is all about coordination with multiple factors, and animate star are used for single factor. Okay, so we do not have a state-based animation, and we need full control over it. That when we should start and when we should end. Then I would say that let's go ahead with animation, and otherwise animation is the only source of truth. Then it's animatable. So animatable, we saw that how we can use animatable during the canvas, and with more control about it, what exactly to draw and where exactly to draw. So that's where we have animatable. Otherwise, we have animation state or animate method. So yeah, this pretty much sums it up. And these are some resources. There is a Compose pathway, and Alex Lockwood's all animations, and he also created 2048 Compose game. And the Jetpack Compose is Joe Birch is writing a Compose book called as Exploring. And Guru Preet Singh has a fantastic Compose cookbook. Leland Richardson is actually working inside the team of Jetpack Compose. So he usually live streams on the Twitch and explains that how Jetpack Compose is working. Sometimes he creates demos, sometimes he explains the code behind Jetpack Compose. Vinay Gaba created a repository, Learn Compose by example. This actually creates alternative comparison, like how recycler view is done in Jetpack Compose, how linear layout is done in Jetpack Compose. So this is a comparative perspective. So thank you for listening. This talk I originally gave at DroidCon 2020. So you can see the latest updated code of this at DroidCon 2020. And please follow me on Twitter. And I have also a newsletter which I usually send monthly. You can subscribe to me at this. And thank you very much.
Sweet. Yeah, let's get some more of those clapping and other type of response emojis. Yeah, some clap ones. Sweet. Awesome. We're going to give everybody like a couple. Well, firstly, no, thank you, Wajahat. That was wonderful. We're going to give everybody about 5 minutes or a few minutes to write questions in the Q&A area, and as well vote on the ones that resonate with you. So yeah, just go for that. Also wanted to give a big thank you to Mahmoud Alim and Shady Salim for producing Arabic translated versions of the slides. For anybody who saw it, I posted it right at the beginning of the talk, and yeah, thank you guys very much for doing that. That was going above and beyond for trying to internationalize the event and try to support people who just want to have Arabic as opposed to English, which is the standard for engineering, but it doesn't mean it's your favorite language to have to read. That's totally reasonable. So yeah. Yeah. Okay. Seems like some questions are still going. How do you feel that went?
Can I see the screen, or can I stop sharing?
You can stop sharing for sure.
Okay.
It seems like it's kind of moving slowly in the Q&A area. So unless another thing gets posted in the next, a few seconds, we can shift on to actually getting it answered.
So we have the first question: how Jetpack Compose will help server-driven UI, and will it be as powerful as server-served web pages? Abdullah Hanif. So server-driven UI is something which is done in a lot of big companies, and Jetpack Compose, the biggest power lies in declarative UI. So currently, in our traditional approach, we are limited to do server-driven UI. For example, you cannot change the edit text, underline color, or radio buttons, tint color at runtime without using any XML themes or that. So then in that case, you will have to either use flavors or either you have to use your own custom component. So these are the limitations which current XML-based Android provides us. So in that sense, Jetpack Compose is more friendly with server UI. In fact, a lot of folks are already working on it, and they Joe Biden figured it out that Compose will work played very nicely with GraphQL, and if that's about server-driven UI. So idea is that you have to create a design system on both server and client to create a proper communication channel, and then you render the component based on the data you get from the server. So yeah, regarding the it's powerful as server-side web pages are not. So far, I have observed that Jetpack Compose is very fast and very performance, and I have not seen any problems compared to our original visual traditional XML views. So I think that it won't have any issues too. So I hope that answers your question. So how is the performance in comparison to XML rendering? Okay, I thought that I given this answer briefly. So, Ninan, we have XML. Uh, Initially, we had XML with nested hierarchy. Then, the more we went ahead, we figured it out that we should actually make it more flattened and straight. So then constant layout came up and all the things to improve the performance. Jetpack Compose is entirely nested, and it works in a nested hierarchy. So at first impression, you probably would be thinking, "Oh, this will decrease my performance," because we are coming from that mindset we are used to for the whole year. But Jetpack Compose underlying architecture is completely state based, so it will not redraw everything on every composition, as they say. So it will only update those components whose states are updated. So this is actually very powerful, and uh, their their structure is so much powerful that we don't feel any performance lag at all in the animations or even inside the Jetpack Compose complex UIs. Yeah. So okay, I see that in Compose, people use hard-coded sizes like 20.dt. How these hard-coded sizes will be managed in responsive app? So, very good question, Zaim. Whatever you saw in the slide, those were just for the purposes of examples. But whenever you create any new project inside Jetpack Compose, you get these colors inside material, and you get these dimensions, and you get these themes. So ideally, a good practice is to uh, use that values not hard coded. Instead, use these values from these constant values. So this will give two things: number one, consistency, and number two, it will avoid the problem of creating strange behavior on UI. Regarding dimensions, you can also use the existing material components and dimensions inside Compose. through an adapter which Chris Bench created. So, but I think that if you are using the existing, if you are adding Compose in your existing application, which had already a lot of legacy views, then that adapter is very useful. Otherwise, I think that you should create, you should use the Jetpack Compose native way of doing theming and everything in the new project. So thanks for the talk, Bajar. Where's the animation panel that you showed? Is it a plugin or is it built-in? So it's inside the it's inside the Compose preview inside in the Android Studio. So uh, whenever you are adding add preview annotation, it will show you a panel with preview, and inside that there is a very small button about where is a small button of animation inspector. It will look like something onions, multiple onions. I couldn't show you right away. So uh, it will be in interactive animation inspector. So if you had any transitions or any that kind of API, then it will automatically pick up from that composable of preview, and it will show you the all the layers and whatever animation transitions you created. It was a good question, but if you just ping me on Twitter or something, I will show you exactly. I cannot explain it here. So yeah. So how is Compose able to keep animation smooth when the entire view tree has to be recreated and diff? Is the rendering the same technique as reconciliation in React Native? So Sri Harsha, I cannot say anything about this because I have not used React Native, but I would say that yes, the animations are based on mostly states, and Jetpack Compose is a sort of function is a UI is a function of state, that kind of mindset. So whenever any state variable changes, Jetpack Compose will pick it up and only update all those components which actually get affected by the state. So yes, it's rediffed and recreated every time, and surprisingly it's very performant because of the underlying architecture inside it, but I don't know the exact details of it. So, any docs that show all the available animation APIs and their behavior. So yeah, I will share. Can I share here or should I share somewhere else? So we have so this is the demo of whole application. This will also come in handy. And then inside the slides, at the last slide, where I shared the whole navigation graph of the animation, uh, that which animation should you be using. Uh, that will actually contains a small link. Inside that link, there is a whole bunch of this very detailed article explaining that what kind of animation does and how and where to use. And I picked that graph actually from that slide. So that will give you the whole perspective about what are the animations and APIs and their behavior. But again, Compose is very new, so you will have to do some research. There are a lot of articles now coming up on animations as well, but mostly I learned it from diving into the Jetpack Compose sample source, which is on cs.android.com. So you go ahead and open this website and write Jetpack Compose, and you will see the whole Compose code along with the samples, and then you'll have to figure it out that how those samples work and how those samples play out, and it's more like R&D stuff. Yeah. So yeah, that was last question, right?
Sweet. That was awesome. Thank you very much.
Oh no,
All right.
I want to thank you everyone for arranging this and for accommodating me in Ramadan, especially Julian Salvi for his swapping the slot with me. So it was very nice of him and kind of you. And it was also I also like to thank all the people who actually translated this slide into the Arabic, and it was very nice gesture, and I did not expect it, and it was very inclusive and accessible for those people who may not understand English. So it was very nice of you. So yeah, thank you everyone. Thank you.